All right, we're gonna get, oh, not that screen. We're gonna get into doing some updating animations with calculus. So depending on how comfortable you are with calculus, that'll really be up to how well you're gonna follow this. But I'm just gonna assume that you know how like what slopes are, how to find area, like integration, differentiation, just with 2D stuff, basic high school stuff. So really, we want to be able to understand this function called always red raw in manim. It's very useful to update stuff to make the animation come to life, and we're going to use a couple updaters, and we're going to use value trackers. They are the most useful thing, at least at a basic level, to make some animations come to life pretty nicely. So we're just going to start off by creating some graph scene stuff. So actually, let me just get this up. This is what I want to do. So I want to create this animation here. So I want to create an axis that has a function, which is a parabola. I want to make a slope pop out and then go back. Okay. Then I want the area underneath the graph, and I want it to visibly be rectangles. And then I want to create kind of like a coordinate where the dot and there's a vertical, I know that's a horizontal line to the graph. So I want to create a bunch of stuff, and I want it to move around too. Like I want it to move around nicely with one another. And so, all right, so that's what we're going to try and make. So we've got a whole bunch of stuff that we've got to get there. First things first is we need to create that axis. So I'm just going to copy and paste it because I really can't be asked typing it out again. So that's it. So we had, it goes from -5 to 5 on the x-axis, -10 to 25 on the y-axis, blah, 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 blah. And we set it up, animate it, all that stuff. Now, I wanted to create a graph, so I'm going to say that is, it's going to be x squared. So self.get graph of lambda such that x is going to become x squared for the x minimum of -5, the x maximum of 5, and the color to equal purple. I need caps there, purple. Now, oh my God, can I type? There we go. So just to show you the power of updaters straight away, I can do this, right? I can just create this graph and then wait. So we're going to run this out here. So we're going to get manim 5 lec, cool. Great. And what I'm also going to do is this is lec 5 calc. So this is just really to illustrate the point. So this is just going to create the graph and then have a function on the axes. I'm going to close some stuff because it's just taking forever. And it shouldn't be. Cool, so it should create something like this. Right, as we expect. Now, have I dropped any frames yet? Oh, I've dropped a couple. Let's lower this. If I've dropped a couple already, that's not good. Apply that, okay. So really, instead of saying, well, let's say I want to make this graph create itself in some sort of a, like, I don't want it to just go from start to finish straight away. I want it to go from like the start point to some other point, but I want to be in control of it. So I want to animate that myself. So I use this always red raw function. And so then I've got to put a lambda underneath outside of that. So we're saying always red raw such that there is a function within a function. Now I know that's going to sound kind of weird, and make sure your parentheses match up there. But the way that this is useful is now we add a value tracker. So I'm going to call it K, and I'm going to say I'm at -5. That's where I want it to start. And instead of X max, it's going to start at -5, and it's going to go up to K.getValue. All right. And so now that's all the parentheses. So instead of showing the creation of the graph, I'm going to add the graph. Nothing should be there. And then I'm going to wait. And then I'm going to go self.play K.animate set value. And I want it to become, actually no, just to illustrate, I want it to become 2 with a runtime of 2. And then I want to actually move it back. So animate.set value, and then I want it to go back to -3. Okay, so let's see what that looks like. Alright, so we've got our axes, and then we've got the graph. It creates it to a certain point, and then it moves back, as it should. I'm in control of this now. So as soon as we add value trackers, and this always red raw to whatever you're putting the value tracker within, that's pretty much all there is to it, right? So we're just going to have a play around with it like that. It is as basic as that for basic stuff. Okay, so I'm just gonna stay in control of this. So now I want to add a slope. So I'm gonna say slope is equal to always red raw lambda. So I'm gonna read this as a function, and I'm gonna say it's self.get secant slope group, and I want that secant slope group to be so I'm gonna have x is equal to and I'm actually going to introduce another value tracker. I'm going to say r is equal to value tracker, and this one I'm going to have it at the point of -3. So the x point is going to hit r.get value. It's going to go up to the graph, and it's going to have a dx equal to 0.01. And I'm going to make the line length a bit smaller. 2.5. Okay, so that's going to animate that out. Now I'm going to add the graph and the slope. Now I'm controlling these with two different value trackers. So I'm going to self.play k.animate set value, and now I want the k to go up to, I don't know, let's say 3, and then now after that I'm going to have the slope move. So I'm going to say r, animate that, set the value of that, and I want it to go from, actually no, I don't want to add the slope at that point. I want to add the slope here, otherwise it's just going to be a random slope sitting there, which is not really much fun. And I want it to add, I want it to set value, and I want it to move to, let's say, the value of 2, and then we're going to reevaluate after that. So we can do some multiple animating a couple of things here. Oh, it doesn't want x equals, it just wants r.get value. Fair enough. Whatever. Alright, so this should like show the creation depending on how we've created it with the graph, and then yeah, there we go. So there's the slope it plays through as well. And we can also do this with areas. Right? So area is equal to self.get Riemann is RIEMANN rectangles. Right? Now I want this to update, so always red raw, right? If you want it to update, you add the always red raw function with a lambda such that, and then just put an enter there. Now I actually want this to be manipulated with the exact same value as k here. So maybe it's worth pointing here that we've got, this is tracking the end value of graph and area. This is just a little, if you put a hash, you can make a little note, and then this is tracking the slope, just so you don't get confused with them. You could also name them instead of k and r, but you know, why would you do that? Anyway, we want this hit to graph. We want dx to be equal to 0.1. I want the x minimum to be equal to, let's say, -5, and I want the x max to be equal to k.get value. So this will be creating some nice rectangles with the slope, and I don't really care about the input sample type. Leave that there. And so now let's see what this looks like. So now I'm adding an area, and the area should be manipulated by the k value tracker, which is kind of nice too. So we see how that pops out. It should come up here. Sweet, plays along. Hey, what happened? Oh, because I didn't add the area. add graph and add area. There you go. Hadoop. Cool, take a bit longer now because it's actually loading some rectangles here. So anyway, let's see what that looks like. We've got, yeah, it pops up. Cool, so the rectangle's created. You can't really see it well because it's green, but we'll watch that again. The rectangles were created with the graph. Yeah, cool. And then the slopes played. Fair enough. All right. So this is all well and good, but we're just using functions predefined by Grant. Thank you, good sir. But let's say we can just define our own shit instead. So we can do our own stuff if we want to. So for example, Grant doesn't have a horizontal line to the graph. Not that that's really useful, but hey, what if you wanted one? You could define your own stuff, and the always red raw works the same. It works the exact same way, right? So let's say I'm going to define some horizontal functions. So I'm going to say def horizontal line to graph. Now this is going to take one parameter. That one parameter is x, but like I just want to illustrate here that it doesn't matter what you call it. The code's going to read it however you input it. So let's say I'm going to input the value of penis, and I want to return a dashed line that goes from self coords to point. And now if we just have a think about what a horizontal line is going to do, okay, it's going to go from, if I zoom in here, a horizontal line will go from like this point here, which is x being 0, y being whatever the y value is, and it goes to x, y being whatever the corresponding y value is of the function, and then it goes to x, which is going to hit whatever the value of that function is at some particular x point, which will be our penis point. That will be our penis point. And so we want it to go from 0 up to a graph.underlying function, and we're going to input our penis point there. And after that, we want it to go from .1 to self coords to point. And we want to go from the point of penis through till the graph underlying function, so that y value of penis. Stroke width 5, thick boy, and let's make it a nice blue color because that seems fitting. Now, and also actually what I am going to also do, you could like do this in one definition, but just to illustrate here, you could also get a get dot on plane. You can call it whatever you want. I just like to call it a nice thing. And let's say our input is kunz. So we're going to put some kunz in, and we're going to get a dot on the plane. And so we're going to return a circle, which has got a radius that's really small, so like something like 0.7, and I want this stroke color to be equal to yellow, and yeah, and I want to move it to self coords to point, and I want it to go to the point of kunz graph.underlying function of these kunz. And so that'll give me a nice circle that is at that point also. So now let's add this stuff here. And I'm actually going to add a value tracker of P for penis. And I'm going to say that's at the point -3. All right, so this is going to track the horizontal line. Yep, and so now we need to add them. So h line is equal to always red raw, because I want it to be updating lambda such that we want to get horizontal line I want to make this get, because I want it to be some sort of a getting method. Get horizontal line to graph. And it's going to input one value. So instead of inputting the value of a penis, we're going to input the value of p.getValue. And that's all the brackets we need there. So this will update the vertical line such that p will be the value that goes into this, and so p will be the value of the penis. So whatever the value of p is that's going to be tracking it, it's going to be tracking a constant updater of the p value, which is the penis value. And we also want a dot. So I'm going to say dot is equal to, again, always red raw lambda. Now again, I could have defined this as one function to make it like a nice compact thing that calls everything, but this just for the purposes of illustration, we want to get dot on plane and I want to have p.getValue. So it's going to be tracking the same value. We'll be tracking both. I want to show creation of the vector group, which is hline and dot, and we're going to wait, and then we're going to see if this works. So p.animate.set value on, let's make it go from -3 all the way up to 4 with a nice runtime of 4, and then we're going to self wait. Now we're going to run this and see what it looks like. Yeah, so it's coming along. Come on, chop chop, bud. It's because I've got, like, you don't code on a laptop and stream at the same time and render. But that's what I'm doing. My poor laptop. RIP, son. RIP. It'll come along. It's like another 30 seconds. Okay, and after this, I'm going to show you, like, this is working nicely in GraphScene, but as soon as you hop out of GraphScene, you don't get to call any of this stuff that Grant's made. It's like, you don't get to say, oh yeah, get seek and slope group. If you're not in GraphScene, you lose all those privileges, right? So if you wanted to have a different axis set up, you would have to redefine all the stuff that Grant's got within the GraphScene template. So, like, if you wanted to call this on a number plane, you got to redefine it. Now, really, it's just a bit of copy paste, but anyway. So we'll see how this looks. So we know what the first bit's going to look like, so we'll skip it. But then here, yes, that's what I want it to do, right? And so it's behaving exactly like it should, okay? And it actually even follows up the parabola. I just need to get that end value up for the parabola. Okay, anyway, so that's working within GraphScene using this. And notice how many times I've used this always red raw. Like, it's all I'm using for updaters, right? I know there is the add updater method. I will typically only use that with, like, decimal numbers and stuff like that. But actually, to be honest, even still, I just use always red raw. It's like the most compact, easiest way for basic stuff. Now, let's make a new one. So let's go class lec5 calc on plane. And now we're going to do this without GraphScene for just a moment. Not too much of a moment though. So we're going to construct self. And so pretty much this is what I want to happen. I want to create a number plane and have a slope go along the number plane. Because let's say I don't like the look of the graph. I want a number plane. I don't know. Or maybe you want two graphs going at once, and so, you know, in GraphScene you only get the one graph, and so that, you know, it's got its own limitations. So maybe you want to be able to do that. So you can do it. It's a lot more effort, but you know. So I'm just going to have this whole plane here, which is the copy paste, which I've got in the Discord, which is just plain config. tweak it however you want, all right? So we can have like you've got your minimum, we've got, yeah, so we've got numbers to show, we've got a unit size, right? However big it is on the screen, we can tweak all those things there. So I might make that 0.75. I might make this 0.35 if I want it to be smaller. All right, so I've gone through that in a previous lesson. And, you know, let's say we're shifting the origin, right? So we can move it around there. So all that's done is it's just created a number plane, which is like, that's like the building block. Now let's put some stuff on the number plane. So we can do a graph. So we can say, instead of saying self.getGraph, you go plane.getGraph because you're getting it on the plane. And we can go lambda such that it's going to hit x squared with an x minimum of, what do we want? -3. An x maximum of 3 and a color equal to yellow. Okay, and then we want to create the stuff. So write the plane, show creation of the graph, wait, and here we've got and I'm going to just copy this so I don't have to re-put it in every single time. Enter that, and all that's going to pop up is we're just going to have a number plane and then a graph pop up. Which is kind of boring for the time being. Okay, but you know, that's what we should expect. Now I could actually change this number plane a bit. If I want it to go higher up, I can change this unit size like I might make it 0.6, okay, because I want it to be a little bit higher. Anyway, and I like to just minimize that there so it looks nice and compact. Now, if I want to create like a slope, I'll say, okay, slope is equal to self.get secant slope group, right? Just like I did before, right? And I can say, well, I want to get k.get value, just like I did before, and I want it to hit the graph. And I want dx to be 0.01, and so you go, okay, yeah, cool. So I need a value tracker for that. So k is equal to value tracker, and you start getting a bit excited, and you're like, all right, cool, and it's gonna start at, I don't know, -2, and you get a bit pumped, right? And you go self.add slope, and then you're frothing at the mouth at this point when you go self.play, and you go k.animate dot set value. And then you go, yeah, I want it to go up to 0, and then self-wait. You're like, sweet, I'm going to run it. And then it goes, no, you're not going to run it. Error. Line 105, you look, okay, line 105. Slope says attribute error. Object has no attribute self-get secant slope group because it's not defined unless if you are inheriting from graph scene. So it worked because we inherited from graph scene. This time here, we're inheriting from scene. So not so simple. If you want to do something like this, we've got to create our own thing. So I'm going to say, I'm going to define get slope. Actually, I might say secant slope. And my input is going to be some value X. I'm going to put tuna because it's my favorite food, just so I can make it very clear that you're just inputting some value, and if we assign it the name tuna, then every time we reference it, like, it doesn't have to be X, it doesn't have to be graph, be whatever you want. Okay, but if somebody was looking at this code and they were trying to like actually make it, and they might get a little bit annoyed at the fact that everything's called tuna. Anyway, so I'm going to say dx is equal to 0.01, p1 is equal to plane coords to point. So this is going to be my first point, and I want it to go from tuna to graph.underlying function of tuna. And then I want a p2, which is equal to plane.coords to point, and I want it to go from a tuna plus dx up to graph underlying function of tuna plus dx. I want the secant to be a line that goes from P1 to P2, and I'm going to scale it. So secant.scale in place and let's go 1.5 over secant.get length. And to be honest, I've just done that because that's actually how Grant did it in his graph scene. And I'm going to return the secant, right? So it's going to return this line that's been scaled that goes from 0.1 to 0.2, which if we know some stuff from calculus, it's like, yeah, okay, that's how it works, right? And so now I guess say slope is equal to always red raw. So now I want this slope to update and lambda such that we're going to have get secant slope, and I want it to say k.get value, and this k value here -1, right? Alright, so now we've added that in, very nice. So here I'm going to say, yep, so now when I add slope, I'm going to add this thing here, which is that slope, and now it's going to animate to the 0.0. Actually, I might have it go to the 0.2. And now when we go to run this, we should be all good. Here it is. Okay, this is my problem. When we're writing always red raw, we're not actually putting in some x value. So it's just, we just want lambda such that. Cool. Because we want it to just always read this thing for whatever values we're putting in. Cool. So I've actually made a couple mistakes that you probably could make, that now you've seen them, you can be like, oh yeah, I know why that doesn't work. Yep, and there's a slope there. Cool. You could add a dot to this, right? So I might just get secant slope group. Like if you wanted to be a little mini Grant here, group, okay, and you could actually define some extra stuff on here. You could say dot is equal to dot, and you want it to move to the point of, let's say move it to P1, right? Just so it's going to hit P1, because that dx value should be so small that you actually won't be able to tell the difference, right? And let's say we want to return the result, where the result is equal to the vector group of secant and dot. Okay, so now we're going to see how this changes things a little bit. Now I've changed the name of it. Right, get secant slope group. Okay, this is not the same as Grant's. This is one I've just made up. Probably should give it a different name, but it's how it is. So now there should be a dot on this secant line, and it always updates with it. Cool. Okay, so that's kind of nice. You can add, like, the nice thing with defining a function is that this is where your animations can become yours, right? Like, you're not just stuck with a generic template that somebody has made and uploaded. Like, you can make whatever, and like generally you use the templates because they're really, really good, and if you tried to create it, it would be pretty shit. But sometimes what you're thinking of just does not exist. Like, there's no template for it. So if you've got the ability to, create some stuff here, and so like we can put more values in here. We could say graph, right? And tuner, and so every time it reads graph, okay, it was going to read graph there. So I'd have to say graph is equal to, actually, no, I'm going to call it func just to make it very clear. Actually, no, I won't. I'll just keep it as graph. It's equal to graph. Okay, and so then we'll see this reads off like, okay, you know what? Maybe I shouldn't just wing shit, alright, because that isn't working for whatever reason. Anyway, I've got a couple of things that I want you to try and recreate for yourselves. So this is the first one. I want you to try and make something that looks exactly like this within graph scene. So an axis, a cubic, I'll give you the cubic equation. Okay, so you want to create something like this, where it creates the area as we're moving along. So I think about, okay, how the heck am I going to do that? Now I've got code in there, and so I'm actually and there's instructions. Let me just throw in the instructions into Discord here. Okay, and it should look exactly like this. Alright, and then there's a second one which is a little harder. It's a little harder. Okay, and I'm going to slap it in there as well also. So I'm going to pop this one in here. And this is what I want it to look like. So I want you to create two graphs, two number planes. One's a function, and one's a derivative. And it's pretty much explaining e to the x, where the value of the slope, so I should say the value of the gradient, is equal to the y value on this here. And calculus animation, yeah, by me, right? Good on you, Amity, you big goose, right? So that you can customize that however you want. You can use different functions if you want. Okay, but the tricky part with this one is going to be that it's not in graph scene. So everything other than get graph, you've got to define it yourself. And we want it to update. So in order to update, we use the always red raw function. Okay, so that I will slap that in the Discord also. And I'm going to stick around for about 10 minutes. And if I don't see any questions, I'm going to scoot because I've got a lot of other stuff to do. Right, and so if nobody's really needing me right now, I'm just going to briefly go over the code of it and then shoot off. Okay, so with that, I might put on a bit of appropriate music, all right, to code to. Alright, I might actually leave it with just asking some asynchronized questions. Good luck if you're going to be working on